The state machine editor is the view you will use most of the time when developing behaviors in FlexV. Here is where we define our state machine by drag and drop and connecting states. Note the new tools in this view. The most important ones for us will be add state and save behavior. This last one is visible in all views so that we can always save any changes in our behavior. Add behavior and add container are for creating hierarchical state machines. The other tools are quite self-explanatory, so feel free to explore them. Let's focus on the view below where we create our state machine. We can see that the state machine is not empty by default. Every state machine has a single entry point, which is already present, and exit points, which correspond to the default outcomes, finished and failed, that we have defined before for our behavior. Okay, let's start adding the states that we need. First, we need to detect the pose of the part. So let's add a state that can do that. We go and click on Add State, and this dialog appears on the right. Here, we can select among all the state implementations available. So let's see if there is a state to detect parts. We can use the filter, I type detect, and here is I type it, and here is the detect part state. This is one of the states in the HRW ROS factory states repository that allow us to use the capabilities in our robotic factory. We select it by clicking on it, and we give the name as state in our state machine. Again, something short, but that clearly describes what will happen when this state becomes active. Detect part should be OK. Now we click Add, and our phase state is added. We do the same for the next state, which was computing the grasp. Here we go, we add the state, and now I look for grasp. OK, we have compute grasp state, which takes the pose of the part as input and returns as outcome the configuration of the robot for picking it. This will be the compute pick configuration state in our behavior. Let's write it, and here I add it. OK, now we need to move the robot arm to that configuration. Remember that in week 4, you learned that Move It and its move group provide different actions for this. Let's see if there is a state implementation for that. The FlexV generic states repository should include something useful for this. We use the filter again, move it, we type, OK, here it is. We have several options. The move it to joint dyn state uses move it to plan and move the specified joints to the target configuration. This is exactly what we need. So we select this implementation by clicking on it, and we give the state a name. Move robot1 to pick seems a good option. OK, here it is, and we add it. OK, we do the same to add a state to activate the gripper. So add a state, we look for gripper in the filter, and we call the state activate gripper. Here it is, and we add it. The final state in our state machine is to move the robot back to the home configuration. We could add another move it state for this, but we can also duplicate the state that we already have and give it another name. For this, we are going to use the FlexV tool overlay. The tool overlay is a very handy tool that you can activate by pressing Ctrl space. It gives you the following options. Clockwise, copy, cut, and paste, show the FlexV terminal, save, show the data flow, undo, and redo. But let's see this tool in action. To copy the move pick state, we click and drag the cursor around it, this way. Press Ctrl space to show the tool overlay and select copy from it. OK, now we open the tool overlay again. Here it is, and select paste. Here is the copy of our state. We change its name to, here it is, we change to move robot to home configuration. And we are done. OK, we already have the 5 states we need. It is time to add the state transitions. In the state machine editor, we define the state transitions by connecting each outcome of a state with the next state that should become active.